Assalamualaikum warahmatullah. My name is Muhammad Habib bin Muhammad Syari, and today I will be sharing about boiling water reactors. Boiling water reactors is a type of nuclear reactor using light water, which is demineralized water or pure H2O, second most used reactors in the world. Maximum operating temperature around 285 degrees Celsius with Carnot efficiency around 46%, where in real life it's only around 33% to 34%. So how nuclear reactors work? Nuclear reactors is initiated by nuclear chain reaction. By nuclear reaction will create thermal energy through nuclear fission and heat up the light water, and the water will spin the turbine. The turbine in the generator, so that from the kinetic energy, and the generator will generate electrical energy. Around 11% of electrical energy in the world is from nuclear reactors. So in this figure, we can see the flow of conversion from nuclear energy to electrical energy, from nuclear to heat, where the heat will heat up the water, and the steam will push or will move the turbine, creating kinetic energy, and the kinetic energy from the turbine will spin the coil of wire and turn in a magnetic field, creating electrical energy. In nuclear reactors, there is something called nuclear fuel. So what is nuclear fuel? Nuclear fuel here is the enriched uranium, because of the usage of light water, because light water absorbs too many neutrons to be used with natural occurring uranium. The fuel content of fissile uranium-235 must be increased through uranium enrichment from 0.7% to around 4%, and the enriched uranium is packed into fuel rods, which are assembled into a fuel bundle, as we can refer from the figure below. So how does the nuclear fission happen? Nuclear fission occur or happen when a remote neutron hit the nucleus of uranium-235, creating unstable nucleus of uranium-236, and when unstable nucleus will split into two other atoms, or isotopes, which are krypton-92 and barium-141, creating a thermal energy and also 3 more excess electron, where the 3 more excess electron will continue to hit other uranium-235 isotopes and creating uranium-236 unstable nucleus and splitting into two, creating more energy, and the flow will goes on and on and on. And that is what we call as nuclear chain reaction. So if the flows goes on and on and on, so how to control the fission rate? So the fission rate can be controlled by using control rods. Control rods containing materials like boron or hafnium that has the ability to absorb neutrons or excess neutrons, where uranium-235 fission will release 2.5 or 3 neutrons on average, but only 1 neutron is needed. So the control rods will absorb these extra electrons and can be used to adjust the power output of the reactor. So as we can see from this figure on the left side, means on the left side we can see that the control rods is deep into the reactor or next to the fuel bundle, which means it will absorb a lot of neutron, creating lower fission rate, and by that developing lower power rate. While at the right hand side we can see that the nuclear rods are lift up, so that the nuclear fission rate will increase, and by that increasing the power output from the reactor. So in the process of uranium enrichment, uranium-235 is the only isotope that undergoes fission, yet only 0.7% can be obtained naturally. So we need to enrich uranium into nuclear fuels. So uranium enrichment is a process to create an effective nuclear fuel that from the mined uranium by increasing the percentage from 0.7% into 4%. So how the uranium enrichment process can be done? In modern days, enrichment is achieved using a special centrifuge called a gas centrifuge, where it separates molecules by using mass difference, where uranium hexafluoride is fed or put into the evacuated cylinder containing a rotor that will spin at a very high speed, where it will make the heavier uranium-238 hexafluoride to collect near the wall, and the lighter uranium-235 hexafluoride will collect near the central axis, and then the enriched product will be drawn off. Although the centrifuge holds less uranium than a diffusion stage, they are able to separate isotopes much more efficiently. So after all, what are the benefits of nuclear power actually? So first of all, it has great energy capacity, where 1 kilogram of uranium can release energy equivalent or equal from the energy of burning 100 tons of coals and 60 tons of oil. Second, reusability. The fissile material is not completely burnt out in the nuclear fuel and can be reused following regeneration. In the future, complete transition to closed fuel cycle is possible. Next, it reduces the greenhouse effect. So the intensive development of nuclear energy can be considered as a means to combat global warming. So in Europe, it avoids the emission of 700 million tons of CO2, while in Japan, it avoids the emission of 270 million tons of CO2, which are high numbers. And the last part is creating economic development, where construction of nuclear power plants provides economic growth and creates new jobs, where one job in nuclear power plant construction can create 10 to 15 jobs in related sectors. By that, I end my presentation here. Thank you so much for watching and listening. Have a nice day. Bye bye.